यूट्यूब पे देख रहा हूँ। अरे वो लाइव चेक कर रहे हैं। मैं बोला उसका भी कहाँ सारे कहाँ एडमिट कर लीजिए। हो गया ना? मैं बोला उसका भी कहाँ सारे कहाँ हो गया ना?
Hello, I'm audible. Hello. Okay, if possible for those, please switch on the cameras. Hello, please switch on the cameras. Good afternoon, everyone. I hope that all of you are doing well. I'm audible.
Yes, sir.
Okay, so first of all, I'll encourage everyone to actively participate, ask questions, and make the session interactive. It must not like the one-sided session. Is it okay?
Sir, you're audible, but your voice is echoing.
Now it's okay. Hello.
Yes, sir, now it's better. But it's echoing sometimes.
I think now I'm audible.
Yes, sir. Now you're properly audible.
Okay. So first of all, I'll start with a small video. But before that, let's begin with a simple question: that how many of you users of mobile phones, laptops, or a battery powered device in a single day? Hello. Hello, I'm audible. Okay, so let's start with a video. After that, we'll forward towards the presentation and the question answers.
Sustainability and fostering innovation have been the heart of ISA India's journey over the last decade. As the largest skill development organization in sustainable mobility in India, we have made a profound impact spanning 24 states and reaching communities across the country. Since 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through our state of the art Center of Excellence, skill development programs, faculty development programs, corporate training sessions, CSR activities, and a wide spectrum of courses with live and recorded interactive classes, we have empowered individuals with the future ready skills. Additionally, through national and international e mobility events such as the Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Days, and the E-Bike Design Challenge, we have provided a transformative platform for over 4 lakh students from more than 750 colleges and universities to showcase their innovative projects and ideas. Our unwavering dedication to excellence has been recognized with numerous prestigious honors, including the National Youth Award, Indian Star Award, Social Entrepreneurship Award, Titans of Technology Award, and many others. ISA India's initiatives have earned widespread recognition and support from the leading organizations such as Niti Aayog, MNRE, SMEV, AICTE, NSDC, and ASDC. Along with this, endorsement from over 100 plus automotive industry leaders and partnership with more than 900 academic institutions across India. The Center of Excellence, where education and skilling converge to drive innovation, skill development, and entrepreneurship. The Center of Excellence aren't just institutions, they are hub of innovation and transformation. With specialized facility for IoT and embedded system, drone technology, electric vehicles, and solar energy, our centers are designed to equip individuals with the cutting-edge expertise and hands-on experience in the technologies driving the future of mobility and sustainability. This is more than a center. It's a platform for empowering the next generation of leaders. Unite education, innovation, and industry to create an industry-ready workforce equipped to meet the demand of rapidly evolving EV ecosystem. We bridge the gap between academia and industry through cutting-edge research, hands-on training, and dynamic collaborations. Our center stands apart with its state-of-the-art infrastructure, from state-of-the-art learning equipment to cutting-edge hardware systems. Our facilities are designed to provide hands-on experience with real-world applications. Here, students and professionals work with the cutting-edge technologies like electric vehicle powertrain system, battery solutions, charging infrastructure, and a range of advanced testing prototyping tools and machineries, preparing them to tackle the challenges of tomorrow's electric vehicle industry. The center also offers hands-on experience with the real-world applications, enabling participants to work on EV components, testing procedures, and system integration, ensuring they are industry ready for emerging EV technologies and trends. The Center of Excellence caters to the diverse demand of government, academia, NGOs, and industries by providing a collaborative platform that aligns with their respective objectives. COE supports the government's vision for sustainable mobility and skill development by creating a skilled workforce equipped with the cutting-edge knowledge and practical experience in the electric vehicle technologies. It bridges the gap between theoretical knowledge and practical application. It offers academic institutions access to advanced equipment, research opportunities, and industry-relevant curriculum. By providing students with a real-world exposure, the COE enhances the quality of education and contribute to the growth of specialized EV program and research. The COE helps industries by providing industry-ready talent and fostering innovation through research and development initiatives. It collaborates with the businesses to address their technical need in EV hardware solutions, assist in workforce upskilling, and partners on R&D projects, enabling them to stay ahead in the competitive market. Not only this, it also collaborates with the NGOs to promote sustainable practices and provide training that empowers marginalized community. We have successfully developed over 50 plus specialized centers that cater to the unique demand of government, academia, industries, and NGO. The center with Government Office of Kerala, a Higher Education Department, Government of Kerala, Directorate of Skill Development, Employment, Odisha, MSME Technology Center, Mumbai, with academic institutions like IIT Mandi, IIT Roorkee, Calcutta University, LNCT University, Desh Bhagat University, MIT ADD University, UGI, CSMSS, EDCET, PES, and many more. In addition to this, we have developed the centers for industries such as Hero Motocorp, L&T, and for organizations and NGOs including ICICI Foundation, EduNet, Govardhan Eco Village, and foreign agencies such as Krisnel South Africa. Our goal is to establish over 250 plus centers worldwide by 2026, positioning India as a global hub for electric vehicle workforce. Whether it's an engineer, technician, or entrepreneur, our comprehensive training programs are something for everyone. From vehicle control system and IoT integration to energy management and autonomous vehicle programming, our curriculum covers every aspect of the EV ecosystem. These multidisciplinary courses ensures students gain the skills needed to excel in this fast evolving field. Through partnership with industry leaders, startups, and government agencies, we connect students to cutting edge projects and practical experiences. From internship to mentorship and collaborative research, our students gain direct exposure to the EV industry's dynamics. Our alumni are pioneers in the EV sector, designing cutting-edge battery systems, leading research teams, and launching successful startups. Their journey starts right here at the Center of Excellence, where they transformed ideas into impactful solutions. We are committed to staying at the forefront of innovation and building a sustainable, inclusive future. Join us today and be a part of the electric vehicle revolution.
So that was the brief introduction of ISI India. As you saw in the video, ISI India is not just about learning concept, but about building the real practical skills that the industry demands. The focus of hands-on training, industry exposures, and preparing students for the real-world challenges in electric vehicle and the future mobility sector. So I hope this video gave you a clear picture of how ISI India is helping students to transform their passion into clear, ready skills. With this understanding, now let's move ahead and begin today's section. So today's session will be led by Mr. Charan. Let's make the session interactive and engaging. Now over to Charan. Thank you.
Hello, sir. Am I audible?
Yes, Charan, you're audible.
Yes. 1 second, let me share my screen.
I request everyone to please switch on your cameras.
Charan, sir, you can start. Is my screen visible to everyone? Hello.
Yes, Charan is visible. You can move ahead for this.
Okay. Okay, let's begin the section. Good afternoon, everyone. Welcome to today's live webinar on battery management system organized by ISI India. Myself, Charan Kumar Reddy, and I work as a cell testing engineer and EV trainer at ISI India. Today, I will be connecting theory with real life industries. So, how does in real life what will be happening? So, how does
Hello.
this all? Yes, sir.
So, Karan, can you please make it to over the presentation?
Sorry, sir.
Can you make it over the full screen?
1 second.
Add downwards at the fourth option, just before the minus sign. Yes.
It's not right.
Yes. No, it's okay. You can move ahead for the same.
Yes, 1 second. One second, guys. Okay, how about now? So is it fully visible now? My screen is fully visible, right?
Yes, sir.
Okay. Okay, let's begin the section. In this section, we will help you understand how batteries actually work in real life, not just from theoretically, and we will integrate it with real life industries. So we will start with battery basic first, then we will move into cell testings from industrial perspective, and followed by BMS concepts like architecture, safety, topologies, etc. And finally, we will move into the careers opportunities in electric vehicle battery domain. So before going to the topic, I will strongly encourage all of you to note down any questions if you encounter during my section. So we will be discussing at the end of the section. So if you have any questions, please note it down. So in present situations, so we will see, we are already seeing that everyone is shifting towards electric vehicle, right? So because in present conditions, the major setback in electron mobility is that it causes so much pollution when we compare from IC to electric vehicle. So that everybody is trying to shift towards green mobility, which are offered by electric vehicles. So when we compare conventional engines to EV, it comes like environmental free, and it also gives offered some sustainable development for the country. So as you know, the efficiency of an IC engine is almost 20 to 40%. So, but when we compare it with electric vehicle, we know the propulsion unit in electric vehicle is motor, and we all know that this component gives higher efficiency, right? Almost like 80 to 95%. Due to this fact, everyone is trying to shift towards green mobility. So if you see in electric vehicle, the major power source is battery, as it stores electrical energy required for the propulsion. So the electric vehicle range that you want to travel, or the speed of the vehicle, or the safety, charging speed, etc. All these facts depends upon the battery itself. In fact, almost most of the cost of an electric vehicle is battery, right? Almost 30 to 40% of EV cost is battery. So if battery fails, we will be getting that thinking that EV also fails. So in present situations, we all are observing that there are so many failures in EV, mainly due to vehicles shutting down on road, or vehicles shutting down due to some faults, or range drop within 1 year after using it. So these are the major drawbacks that we are observing in present conditions. So this is why testing a cell and as well as BMS becomes very critical. So let us see the basic structure of a battery pack and what are the different chemistries that are currently using for manufacturing of these cells. So first, for a battery pack, we are using combination of cells that are connected together to form a battery pack. These cells are either connected in series and parallel configuration, right? So for suppose let us say a cell is a smallest unit that stores electrical energy, right? And these cells are connected either in series or parallel to form a module, as you can see here. After this, these modules are again connected in series or parallel combinations, integrated with BMS and other systems like cooling to form an entire battery pack. So basically, when you see a battery pack, they will be mentioned like parameters like voltage, capacity, or C rate. If you see on the cell sleeve, they will be mentioning like voltage, nominal voltage, which is the operating voltage of the cell. And you may also see the maximum voltage of the cell that it can go, or cutoff voltage that you can use up to it. And you may also see the capacity, the maximum energy that it can deliver. And sometimes they also mention C rate, right? You all observe these parameters on the cell sleeve. After that, nowadays we are mostly using LFP and NMC chemistries for electric vehicles, as they offer a better performance. When we compare LFP and NMC gives better performance compared to LFC, and as per safety standards, LFP is superior than NMC. And as a test engineer, the test limits differ for LFP and NMC due to chemical difference. So LFP and NMC exhibits different characteristics when compared parameters like voltage, like NMC exhibits like 4.2 volts maximum when compared LFC. So LFP will give for 3.7 as maximum voltage and 2.5 as cutoff voltage for both. So operating voltage is like 3.2 volts for LFP and NMC is like 3.8 like that. So why do you think the cell testing is crucial and mandatory? We know that it comes once a cell is manufactured, it always goes for testing. After once it is tested, it is then used for manufacturing battery packs, etc. Right? So during cell testing, before after manufacturing a cell, it declares whether a cell is manufactured as per industry requirements or as per industry matches. So it ensures that the cell is good or defective cell, or the cell is manufactured according to the specifications or not, as it is working good or not. So we will test this accordingly so that it performs well and it is regulates to the safety standards. So the cell testing is very crucial, so that we will be knowing that if a cell fails in the battery packs, it causes the entire pack to fail. As you know, the cells are combined and connected in series and parallel configuration. So if when cell fails, the rest follows it. So this cell testing is mandatory and crucial. So let us see type of cell tests that are currently or any industry uses once a cell is manufactured. So once a cell is manufactured, then it will go to testing stage to find whether the cells are meeting the industry standards or safety standards. During cell manufacturing, there are different stages like slurry preparation, coating, calendering, electrolyte filling, assembly. These comes under a cell manufacturing stage. Once a cell is manufactured, then it goes to the testing stage, where this testing stage consists of two stages. One is the formation grading, and other one goes to the segregation of the cells. So it mainly tests like IR test, capacity test, charge or discharge cycle test, C rate test, or life cycle test, or thermal runaway test, safety test. These are the different types of tests that we come across. The first test once a cell manufactured is IR test. We know that the components that we are used to manufacture cells exhibit some internal resistance, right? So these internal resistance should be very least, so the losses will be minimal. As we know, resistant element dissipates energy in the form of heat, and the energy, the dissipated energy by heat is hazardous thing, and it should be minimal. So there are two types of testing methods in industries that we come across. One is the DCIR and ACIR method. DCIR means we use direct current, and next one is ACIR, which will be using alternating current. So among them, ACIR gives better accuracy, and we will see some industry equipments like HUQIR testers, chroma testers, Averi testers, like that. So these testers are used to test the internal resistance of a test. Then comes the capacity test. Here, as we know, we will be testing the capacity of test by giving charge and discharge cycle. The capacity of the cell that we see on the sleeve is taken from the discharge stage, but not the charging stage. As we know, we will be considering discharge stage because we will be using the discharge power, right? The capacity, that how much capacity that it delivers, that we will be considering. So then after we will be also seeing charge discharge cycle. If there are any abnormalities during charge and discharge cycle, we will be considering it as a defect or good cell. So there we will be observing the voltage or current graphs. If there are any abnormalities like voltage sudden spikes or short circuits, we will be seeing them. And if there are any abnormalities like spikes, we will be observing them, and we will be considering into two stages like good cell or bad cell. And thereafter, we will be seeing C rate. C rate is the test how fast a cell can charge or discharge safely. It means that what is the maximum safe current that you can give while charging or take from the cell during discharge. Right? So let us say cell has 4 Ah capacity and it was mentioned as 1C tested safe. It means that you can take 1C rated, that means 4 amps. 4 amps is the maximum safe rate that you can take from that cell, which means 1C rate. Like that, if it is mentioned 0.5C, then you can able to take 2 amps maximum only from that cell. So basically, C rate describes the maximum safe current that you can give or take during charging or discharging. So for a cell having 1C, it is like the maximum current it can deliver and give is 4 amps. So the range will be 0 to 4 amps, right? For the 1C test, 1C C rate. So like that, there will be a major C rate test like 1C means for a 4H capacity, you can take 4 amps. 2C means you can take 8 amps maximum. Like that, 0.5C means 2 amps is the maximum current that you can take from the cells or give to the cells. Example, if you see mobile phone battery, they mention like specification like the battery can be charged within 1 hour, right? You may observe the 5000 mAh battery in your mobile can be charged within 1 hour, right? So it means it is giving the charger that you're using gives 5000 mAh, right? 5 amps per hour, 5 amps continuously, so that it can be charged within an hour. It is called 1C rate, the maximum. It is also describes the time as well as, so depending on the C rate, you can also calculate how much current, how much time it can take, or how long the battery can last if you take that much of current. So then after there is life cycle test. Life cycle means the number of charger discharge cycles a cell can complete before its capacity drops to a defined limit. Generally, the limit is 80% of the battery defined capacity. So let us suppose say the capacity of a cell is 1 Ah, and when you use it like charge and discharge heat up to some certain amount of times, you may observe that there will be a decrease in the capacity of the cells. Like it may decrease to 0.8 Ah or 0.9 Ah. Initially it was 1 Ah, but later it was degraded to 0.8 Ah or 0.7 Ah like that. So life cycle test describes that how many cycles it can give, so that the battery can still give you 80% of its capacity, right? So it predicts how long the battery will last. So generally for LFP or NMC cells, it will go for from high 500 cycles to 2000 cycles. So as you can see, these are the testing equipment and these are the testing methods that our industries use. Initially, the IR internal resistance test, they will be having cell positive, which is cathode and anode, directly connected to the pros. This is the equipment, Hayuki equipment that you are using for internal resistance. Here, the equipment is set to internal IR testing method. So it will measure the internal resistance of the cell, which is with the method that uses here is AC IR, which is more accurate when compared to DC IR. So after that, as you can see the next graph, there you can see the cycle test or charge or discharge cycle test, or you can say it is also a type of test comes under a capacity test also. So here the cycle test describes the efficiency of the cell. As you can see, there are many cycles. As you can see, it goes to the x-axis, you can see the time, and y-axis, you can see the voltage, and the voltage increases up to certain level, and after that it goes to some rest, and then again it discharges. This is one complete cycle, and after it again repeated, it comes to charging, reaches to 4.2 volts nearby, and then given some rest, and then again discharges. It is again repeated some for number of cycles. So this is cycle test. And as you can say, this is also a charge and discharge test also. So it will give the efficiency throughout the life cycle. So as you know, during first cycle, you may observe the capacity, let us say 4 Ah, and the second cycle, you may observe a little bit less capacity compared to the previous. At first, you may observe 4 Ah capacity, but after that second cycle, you may observe 3.999 like that. And after one more cycle, you may observe 3.998 like that. So that the capacity of the cell may decrease with the number of cycles, right? And as you can see here, we may also observe the charge and discharge cycle test. Here, if there are any spikes during this charge or any short circuits during this cycle, we will be considering as abnormal behavior of the cells and will be marking as defective or bad cell. And thereafter, we will be seeing C rate test. As you know, C rate is the test of the cell that describes how much the maximum current that you can safely operate. So as you can see here, there are different C rate tests, 2C, 1C, 0.5C and 0.2C as well. From seeing the graphs, you may encounter that less C rate offers better performance than high C rate, because for high C rates, let us suppose 2C rate for a 4 Ah capacity, which means 8 amps current we are taking from it. So when we take 8 amps current and 0.2C means around 0.8 amps. So when we compare this, the amount of heat generated to C discharge will be high compared to 0.2C. So we know that this heat generation is very hazardous for a cell. So, and we know that the high currents also degrade the battery life also. So, for a for a cell, the period should be minimum so that it offers better performance. And after that, you see thermal runaway test. As you know, cells are very chemical reactive, and they exhibit sudden changes when if there are any abnormal conditions happens. So they test some thermal runaway, like CRET is some sort of thermal runaway test. As you know, as you are testing it for high temperature, uh, it delivers high current. At the time, you may observe there is a high sudden range, sudden change in temperature. So this temperature must be limited so that we will be testing for temperature test also. So that's why obvious tests like overcharge, short circuit, and thermal tests are performed. And after that, we will be seeing battery management systems, and we are also know that these are integrated with the batteries. So if the battery is the heart, we know that BMS is the brains because it continuously monitors the voltage of the cells and current coming into the battery pack or taking from the battery pack, and it also monitors the temperature of the battery pack and right. So it also ensures the battery operates within the safe limits. As you know, the cells that are used to manufacture the battery pack has certain operating ranges. Like it can be used to these certain limits, like maximum voltage of 4.2 or minimum voltage of 2.5, and it should be used up to 1 or 2 degrees Celsius, or, like that, right? So BMS actually monitors each and every aspect of battery cells, so and it controls and operates so that it provides better performance and better longer life for a battery. So without BMS, batteries are very unsafe, and we know that the electric vehicles uses lithium-ion batteries, and they are very hazardous as they caught fire if there are abnormal activities. So when a battery pack is integrated with BMS, and it ensures smooth operations. So let us see what are the core functions of battery management systems. First thing is we know that batteries are made up of individual cells. So each cell is continuously monitors of their voltages. So after that, it also monitors current which are flowing from the battery or going into the battery when charging. So it also guards the battery pack from any faults, or if you giving overcharging or over discharging, or if there are any temperature increasement in the battery pack. So we must also we are also encountering that the cells that are using in battery packs, if there are any tolerance in between them, it may causes to the cell imbalancement. So it is also a main, it is also plays a key vital role in battery pack. So all the cells in the battery pack must and should exhibit same parameters with the neighborhood cells. So it performs well. After that, we will be seeing temperature control. BMS integrated with the temperature control or cooling system so that it operates with the operating temperature range. And majorly BMS also integrated with the state estimation of battery pack. As you can see, most of the mobile devices that you are using indicates that how much capacity remaining or health of the battery, right? So like that, the battery pack that integrated with BMS also indicates the SOC or state of SOH of the battery pack. Then let us see BMS architecture, which will describe the major components that are integrated in BMS. BMS consists of sensors like voltage to measure the voltage of cells or to measure the current. There will be current sensors to measure the current, and there are also temperature sensor to measure the temperature. If there is any rise in temperature or not, like that. And after that, there will be controller to get the data from the sensors and analyze it. And the controller analyzes the data and sends the response to the auxiliary systems as you can see, there will be hardwares like contactors and relays. So it will send data to these auxiliary systems. And we know that these data can be transferred via CAN systems. There will be some advanced technologies like Wi-Fi, Bluetooth, like that. So these are the communication systems that are used in BMS. And there are also hardware systems in BMS which plays a vital role during isolation when a fault occurs. So these BMS interface with actually battery. It connects with battery, controller, and as well as motor. So it interfaces with charger also. So this is the intermediate in between them. And after that, we will be seeing how a BMS is connected for a battery pack. The BMS topologies defines how cells and BMS hardwares are connected internally. So let us see different types of BMS topologies here. So as you can see, the first one is centralized BMS. Here, each and every cell is directly connected to the main BMS. There will be only one BMS, and each and every cell is directly connected to it. Right? So for one cell, let us suppose there are 10 cells, then there will be 11 terminals coming out of it. So we know that each cell has one positive and negative terminal. Then for as you can see here, 1, 2, 3, 4, 5, 6, there are 6 cells. So each cells have one positive and negative terminals. So as you can see here, positive and negative terminals in between. These are connected in series and they are all directly connected to the central BMS. There will be only one BMS. It is simple, but it is complex if there are many cells in a battery pack. As you know, the wires that are connected here become very complex if we increase the number of cells. But it is easy to implement actually. And then next we'll be discussing about distributed BMS, and we know that battery that is used in electric vehicles made up of cells or in modules. So here in distributed BMS, each cell or a group of small cells have one BMS actually. And then again, these BMS are directly connected to the main BMS. So initially, these single cell are a group of cells connected to first BMS, which will be calling it as slave BMS. And after that, the slave BMS connected to the main BMS, which will be calling as master BMS, right? So the sensors, the voltage sensors data, current sensors data first goes to the slave BMS, and slave BMS sends data to master BMS, and master BMS analyzes the data and again responds accordingly. It is good and very recommended for electric vehicles. As you know, these actually that we are using battery pack, they are made up of individual cells, right? They're connected in series and parallel. So using these distributed BMS either in modular becomes very easy and accurate. And after that, we will be seeing modular BMS. Here we know that the cells are first converted to modules, and again modules are again converted to battery pack, right? So here battery pack is made up of modules. So each module here you are using each module for one BMS. So each module has one BMS. Like that, there will be some modules for each and a module for BMS. So these BMS are interconnected with the each and individual module. So the data or the census data, whatever, the data from each modules is interconnected in between the battery packs and operated accordingly. After that, let us see why cell test data helps the BMS. Have you ever wondered what is the use of these cell test data that we are using in BMS? So how this test data actually help in BMS? So basically, BMS are made using these cell data because it does not know what are the operating ranges of a cell or what is the fault or even what are the abnormal conditions. So it does not actually know what to do. It does not actually doesn't know any operating ranges of a cell. So as you know, we are using different chemistries like LFP and NMC. We also know that LFC exhibits some other behavior and NMC also exhibit differ to LFP. So BMS does not know that. It only operates whatever the data given to it. So there will be some algorithms in that. So it will act according to it. So the test data of cells are initially used for BMS and it sets some algorithms for BMS. So the data describes how cell conditions like operating stages, minimum and maximum operating stages, what are the abnormal conditions, it sets that algorithms. So without accurate test data, BMS does not know the operating conditions for a cell. And also it does not perform SOC and SOH calculations accurately, right? So when we test a cell, we will collect the data and we will send it to the BMS controller. So it will store the data and analyzes accordingly. So it may know that during this test, it will be knowing that this set is the operating range. Like for an MC cell, it may set like 2.5 is the cutoff voltage and 4.2 is the maximum voltage. And 3.8 is the normal average voltage like that. And it will also predict the life cycle data. During life cycle test, it will predict how many life cycles it has used and what is the health condition of the cell. And we also know that the cells that you are using in battery packs have some tolerance. Because let us suppose that an industry manufactured a 4Ah capacity, and we also know that every cell does not exhibit 4Ah capacity. There may be some tolerance, like some cells give 3.98, 3.99. Some cells give 4Ah, 4.09Ah, right? So these capacities also exhibit some voltage difference between these cells. Due to this capacity difference, one cell may discharge very fastly and one cell may discharge later and one cell charges very fastly, right? So depending on these cell test data, the BMS getting to know that these are the test data and it will act accordingly, right? And the major function with this test data is cell balancing. As we know that there will be a difference or there will be tolerance in between cells. Like if one cell exhibits 3.7 volts and one exhibits 3.8 volts, there will be voltage difference. And the rest of the pack try to force to give 3.7 volts. So it may cause thermal runaway. So what BMS will do is, it will make the rest of the battery pack cells come to 3.7 volts, right? So that all the cells are at same standards, so that they perform well, so that it does not cause any abnormal conditions. So let us see some real life electric vehicle conditions. So when we charge an electric vehicle, so if you give a fast charging, so BMS continuously monitor the current flowing into the vehicle. So if any abnormal current happens during that stage, it will detect it and cut off the power supply. And as you know, there was an advanced technology in electric vehicle which is regenerative braking. So we also know that the regenerative braking does not it is not actually a constant supply. We know that there are many fluctuations coming from it. So BMS has been analyze this power first, and then uses this power to charge the battery. And we also know it is also integrated with the thermal system, which is a cooling system. So if any sudden rise in temperature, it will detect and inform to the cooling system so that it will optimize the battery pack temperature. All these are controlled by BMS so that the battery pack can deliver better performance. Let us see some BMS values that we are currently observing in an electric vehicle. The first major failure is cell imbalance. As you know, the industries does not perform better testings. So the major consideration is cell imbalance. If there is any imbalance between cells, it causes the enter back to fail. And after that, we are also observing over temperature during charging as well as discharging. And also, if the cooling system fails, then the BMS also fails to manage the temperature of the battery pack. Due to poor cell test data or poor sensors data, the BMS fails to calculate the SOC also. And it will also lead to the inaccurate SOH calculation also. And BMS also fails if there are any loose connections, like there may be loose connections when you are moving, so that there will be fluctuations from the battery pack. It may also cause BMS failure. So to overcome these failures, we must use better testing data, which must be accurate first of all. And also the tests that we are doing for cells must be done with the calibrated equipments, right? Let us move to the next topic, which is battery safety and thermal runaway. So let us see what are the different failures that are come across during battery, and what are the roles of BMS to prevent that failures. So first one is overcharging. We know that the excess energy during charging when a cell is already charged causes power dissipation, and power dissipation causes heat, right? So due to this, it may cause thermal runaway, it may cause burst. So to prevent this, BMS continuously monitor it, and if it detects that battery cell is fully charged, it will cut off the charger supply so that it will prevent overcharging. And then after we will be seeing internal short circuit. Due to short circuit, there will be high currents are passed through the cell, causes sudden change in temperature, which again causes thermal runaway. So BMS again monitors it. If there is any sudden changes or sudden rises in temperature, or if there are any sudden current increases in the BMS and battery, it will detect and isolate the system. And it will the major defect of a battery cell is we may encounter is mechanical damage. Like if there are dents or crimping issues, like the cell is not properly crimped or not properly managed in the slots, so it may cause cells to burst, or it may cause cells for thermal runaway. So the cell must be inspected initially. After that, we will be using it for the battery pack. So BMS prevents failures by continuously monitoring the voltage or current of the cells. And if any abnormal situation occurs, it detects it and cut off the supply. Let us see what are the different career paths in electric vehicle domain. The first one is cell testing engineer or battery testing engineer. There you will be testing cells as for physically or electrically. For physically, you may be testing like if there are any dents or if there are any crimping issues like that. And after that, as per electrical parameters, you may be checking like capacity testing, IR testing initially, and after capacity testing and charge discharge testings, life cycle testings like that. And you may also testing thermal runaway test or safety test like that. And after that, we will be seeing BMS engineer. There you will be developing a battery management system that is capable of performing well for battery to optimize it. The BMS engineer mainly focuses on designing power electronics devices so that it can perform well. As you know that there will be integrated with cell balancing technology, or thermal management technology, or overcurrent over voltage protection technology like that. So these comes under BMS engineering. And after that, thermal management systems, you can also work as thermal management engineer. There will be focusing on designing of a battery pack so that it can be well ventilated. It can be integrated with good ventilation and cooling system. And after that, you will be seeing battery pack design. So most of the battery pack designs, there will be battery pack design topologies like series parallel combinations. So the battery pack design engineer will be going to that how to design a battery pack in less space, or you can say well ventilated and less space integrated like that. And after that, there will be more like EV validation engineer. There will be test the entire vehicle performance, or you can say the operating of electric vehicle. So you can increase the performance of an electric vehicle. How can you increase the performance of electric vehicle? These are come under electric vehicle validation engineer. And let us see the future of batteries and BMS. The first one is when it comes to batteries, we may observe currently we are shifting to lithium ion, and the major drawback in electric vehicle is it does not go for a very wide range, and another thing is it does not charge very fastly when compared with the IC engine. So to offer these IC engine facilities, the batteries actually we are using, trying to shift towards fast charging. And there is one more technology called BSS, battery swapping technology. It offers same as IC refueling convenience, right? So this is the main advanced technology for batteries. And after that, we will be seeing fast charging like a DC fast charging. And after that, we'll be seeing battery management system where it integrated with AI. Here, AI is integrated with BMS so that it will read the test data accurately, and it will predict. And it will give accurate SOC and SOH prediction. And after that, you will be using advanced diagnostics So that as you can see present, they are only focusing on electric vehicle diagnostic tools, so that it will diagnose the entire battery pack and it will diagnose the entire vehicle. It will detect any faults in the vehicle. After that, we will be seeing solid state batteries. So there will be using solid batteries. It will be good for electric vehicles as it offers better safety and higher energy density. If energy density increases, we'll be going to that the capacity or as well as the performance of the battery also increases. That's it, guys. I hope you understand this section. If there are any questions, please feel free to ask. You can use chat box as well. If you have any questions regarding how industries test the cells or battery packs, how our BMS are integrated with the battery packs.
Hello. If anyone have any question, can you please raise your hand? Next 1 minute. Hello, I'm audible.
Yes, sir. If anyone has question, please use chat box or you can unmute yourself and ask directly.
Thank you, Charan, for the excellent session, and thank you all of the students for participating and stay connected with ISI India. And we'll be connecting you for the same for the upcoming sessions on the different emerging technologies topic. Before ending with the session, I'd like to introduce to a course that we have currently launched along with the AICT. So we have connected with AICT course, which you can check on the website also. The program is titled with AICT approved master certification course in electric vehicle technology along with ISI India. So along with this course, we have defined the 6 modules along with the topics. It is basically to address the gap that ISI India has developed this master certification course in electric vehicle technology. And this is a 6-month structured certification program, which will be delivered through online classes combined with hands-on projects and industrial training through ISI India and the COE labs nearby you. So basically, it has 6 major segments, which is EV fundamental and vehicle architecture, electric motor controllers and power electronics, battery technology, BMS and thermal management, vehicle integration, wire harness and safety standards, CAN communication and embedded systems, testing validation and homologation, and the advanced topics such as ADAS, IoT in EV, and digital twins and the future. Along with it, you will gain exposure to industry standard tools such as MATLAB, ANSYS, SolidWorks, Simulink, CATIA, Autodesk softwares. So for the same, I am giving you a Google Form link in this chat box. Who else is interested, please reach out to me on this number. You can mail me on this mail ID or just fill the Google form. One of the executive from our end will reach you. Hello. Yes, Prince, you can please continue with this.
सर एक क्वेश्चन था।
Yes.
हम ईवी व्हीकल पे क्यों शिफ्ट हो रहे हैं? हमारे पास पावर सोर्स तो और भी है। हम फ्यूल को एज अ पेट्रोल डीजल को छोड़ के ईवी व्हीकल के पास ही क्यों ट्रांसफर हो रहे हैं?
एक्चुअली हम आईसी इंजन कन्वेंशनल इंजन फॉसिल फ्यूल्स यूज कर रहे हैं ना, वो एक्चुअली मेजरली हम इंपोर्ट कर रहे हैं फ्रॉम फॉरेन कंट्रीज, so the cost also increases further. So if you shift towards green mobility, it may decrease depending on fossil fuels, and we know that these IC engines causes environmental pollutions, right? And when you compare with IC and EV does not, it is eco-friendly and it does not pollute, right? And we know, and the major advantages of EV is the efficiency of EV is about 80 to 95%. And when you compare with IC gives only 20 to 40%. Rest of the remaining efficiency goes to dissipation of heat, right? That's why we're shifting from IC to EV. And another thing is the maintenance cost of IC is very high compared to EV, because in IC there are many rotational parts, and in the electric vehicle there are very less. And in fact, there is only wheels and motor itself. They are the rotational parts. So that's why there will be less maintenance cost when compared with IC. So due to these all facts, we are shifting towards electric vehicle.
Okay, along with that, in addition of Charan, I like to tell you that petrols and diesels, basically the fuels have a limited resource. And if I talk about the electricity, it can be regenerated, but the fuels cannot be regenerated, as EV options are limited today. So they are cleaner. I can say they are cheaper to run and essential for the sustainable future.
Yes.
सर अगर हम कह रहे हैं कि ईवी एफिशिएंट है, उसके जो इलेक्ट्रिसिटी है वो रिजनरेटिव है, इट्स राइट, बट हम कॉस्ट की अगर बात करें तो फिर ईवी व्हीकल में हमको कॉपर बहुत ज्यादा यूज होगा, तो वो भी कॉस्टली पड़ेगा। और अगर सामने हम अगर करेंगे कि क्लीन एनवायरनमेंट, तो जब ईवी की बैटरीज खत्म, उसकी लाइफ खत्म हो जाएगी, या फिर उसकी लाइफ अराउंड 5 years या 7 years वटेवर जो होती है, वो खत्म होने के बाद वो बैटरी बहुत ज्यादा पोल्यूशन करती है, ऐसा भी बहुत लोग कहते हैं। तो फिर उसका क्या, हमारे पास गैसोलीन फ्यूल भी तो है।
We are also working on hydrogens also. We are conducting events also for the hydrogen gas, CNG also we are working over. But EV is the more significant because battery is used in every vehicle. Auxiliary battery is used in every vehicle. Either is hydrogen, either is CNG, either is EV, either it's IC.
ओके, इट्स मींस के हम फ्यूल को यूज करना थोड़ा कम कर रहे हैं, बिकॉज हमारे पास अनलिमिटेड सोर्स नहीं, लिमिटेड सोर्स है और बहुत महंगा है।
That can be regenerated, but fuels cannot be generated. Battery can be replaced, but the fuels cannot be replaced, ना?
ओके, तो हमारे पास गैसोलीन फ्यूल है, वो तो हम रिजनरेट कर सकते हैं ना?
But it cannot be refamed. Gasoline can be regenerated, but it cannot be refamed.
ओके, तो हम ईवी, तो मेरे पास दो ऑप्शन है, ईवी और गैसोलीन फ्यूल या व्हाटएवर, तो इन दोनों में से हमको कौन सा ज्यादा प्रीफर करना चाहिए?
See, gasoline is basically the mixture of gas, like CO2 we are using, nitrogen we are using, particulate matters we are using, which causes pollution. And in terms of, I talk about the pollution, it also causes over the terms of health issues, right? And gasoline is not compatible in every temperature, such as it can make problems in the climatic change. And if we are using gasolines over the engines, that you will facing major issues in the terms of maintenance. Next one is lower energy efficiency, because in the gasoline, did you know the formula of gasoline? Majorly the CO2 and NOx is involved over there, right? So there's a loss of heat, because gasoline releases the energy in the loss of heat. And EV, in the terms of electric vehicle, energy much more efficient. And what I can say in the terms of pollution, not only the major air pollution, gasoline engines and produces more noise. So gasoline is not an option, and it's not going to come in next 30 years also, if I say, because gasoline vehicles, in the terms of pollution, if I talk, in the terms of maintenance of I talk, in the terms of cost I talk, they're not sustainable that much in the future as well. Is it okay?
हाँ सर, ये बात है। ओके, तो ये एक वैलिड रीजन भी है हमारे पास कि ईवी पे हम ज्यादा फोकस कर रहे हैं। तो फिर अगर ईवी की बैटरीज की बात करें कि उसकी लाइफ खत्म होने के बाद वो वेस्टेज हो जाती है, तो हमारे पास इसका कोई ऐसा रिसाइकल साइकिल, कोई ऐसा प्रोसेस है कि हम उसको रीयूज कर सकते हैं?
हाँ, बैटरी सेल्स कैन बी रिप्लेस। बैटरी में दो कनेक्शंस होते हैं मेजरली, विच इज सीरीज पैरेलल, पैरेलल पैरेलल, सीरीज पैरेलल। आपने व्हीटस्टोन ब्रिज का कॉन्सेप्ट पढ़ा है? डिड यू नो अबाउट द व्हीटस्टोन ब्रिज?
सर, मैंने ईवी के बारे में इतना ज्यादा कुछ पढ़ा नहीं है। मेरे को इतना ज्यादा
बेसिकली देयर आर सेवरल कनेक्शंस, जैसे मैं आपको व्हीटस्टोन ब्रिज के बारे में बताऊं, तो इसमें एक वेरिएबल होता है, एक नॉन वेरिएबल होता है, एक नॉन वेरिएबल होता है, और एक हमें रेजिस्टेंस इसमें फाइंड करना होता है। ठीक है, तो बैटरी रिसाइकिल इज अबाउट इट्स अ टाइम टेकिंग प्रोसेस, बट इट इज पॉसिबल।
ओके सर।
यस। और यार वैसे भी अगर हम बैटरी की बात करें तो आई डोंट थिंक सो कि अभी की जो बैटरीज है लिथियम एंड विच वी आर ओवर वर्किंग एंड शिफ्टिंग ओवर, आई डोंट थिंक कि कोई भी बैटरी 8 से 10 साल तक से पहले खराब होती है, क्योंकि ऑलमोस्ट कंपनीज आर गिविंग 5-year वारंटी, 3 to 5 year वारंटी।
Even after 5 years, they are still be recycled, right?
Okay.
Even
It is there.
used for secondary like other purposes, or we can directly recycle it by decrimping that and using those materials again for the manufacturing vehicle, right? So basically, even after that warranty, if any failure occurs of battery damages, we will be using those materials again to manufacturing new cells.
Is it okay, Prince?
Yes, sir.
Okay, anyone have any more questions? You can go ahead with it.
And someone asked the skills required for the industry to get hired in the battery section. Actually, you must be aware of that basic battery fundamentals like chemistry that are used in battery manufacturing, like LFP, NMC, and NC, or cell formats. Like there are different types of cell formats: cylinder, prismatic, pouch, etc. And you must also be aware of that what is mean by voltage, current, capacity, and how does a battery exhibit these and charge or discharge cycles, like that. And you must also know that how different types of testing equipments, like I said, IR testers, there will be some charge discharge testing equipments. So you must be aware of those equipments, and you must also know the battery pack arrangements. As you know, the cells are connected either in series or parallel to form a battery pack. You must also aware of that. These are the skills that are mandatory to go into the battery manufacturing industries. Any questions?
Mohammed Ziol, it is clear to you? Hello.
Yes, sir. Yes, sir. It's clear.
Okay. Anyone else? Yes, Balaji.
Actually, we have one question, sir. In BMS, for cell balancing strategy, which one we are following now currently in most of the companies? So, which is the strategy for BMS now doing that for cell balancing?
You're asking the topology that you're using for cell balancing, right?
Yeah, yeah. In currently, if many firmware
Mostly,
will be
there are
released.
two types. Yes.
Yeah, many firmware will be releasing. So which strategy now currently most of the companies are following? So how much delta will be constrained? Suppose we have hundreds of cell. In which one we have to decide first? So this one is the cell, and what is the exactly formula for that?
Actually, we know that cell balancing is major key role of the BMS because depending on that, the battery pack performance increases. So there are two types of strategies. One is active and another one is passive. So passive means we are making balancing by dissipating heat. But in active, we are not wasting any power. Instead of wasting it, we are shifting from one cell to another cell. So most of the electric vehicles, if you see, they use the active balancing strategy actually. Because passive balancing wastes the energy through heat. So nobody uses that. Instead of they go for active balancing, but it is a bit complex and cost effective compared to passive.
Okay, so got it. But in passive balancing strategy, we have almost many cells for considering. So BMS, how to decide the first one cell is it and to be balanced for that cycling, and which SOC it will be considering for in graphical representation. So what is the strategy for SOC?
Actually, if there are, let us suppose 10 cells in a battery pack, and one cell exhibits a 3.6 volts and rest of them are just 3.7 volts. Okay. So the passive strategy says that so we cannot increase 3.6 volt cell to 3.7, right? During discharge. So they are all in discharge stage. So either we can do 3.6 to 3.6 cell to 3.7 volt, but it's not possible during discharge. So we can either do all the 3.7 volt cells to 3.6 volt cell, right? So BMS monitors the lowest level of cell. Like it will gathers the voltage of cell. So it will check whether which one is the lowest voltage, and the remaining cells which are having greater than that voltage, it will dissipate their power so that it will reach 3.6 volts. By connecting to a resistor through a logic gate, they will connect to the resistor and they will dissipate power until it reaches 3.6 volt so that all the cells are balanced. This is the strategy that are used in passive balancing.
Okay, sir. In that passive balancing strategy, SOC will be matter. So how much SOC cell balancing strategy will be on?
Actually, it does not check SOC. It will mainly check voltage of the cell because SOC actually there will be only one SOC, which is the entire pack SOC. Internally, it will be only cell monitoring, which is voltage or current. It does not monitor each and individual SOC. Okay.
Okay, sir. Thank you.
Yes. Any other question, guys?
एक मिनट. Hello. Hello. I'm audible.
Yes.
Okay, so if anyone have any queries, you can continue. And in the chat box, I have given a Google form to who else who are interested in the AICT NEET program, the certification program, the MD certification program by ISI India and AICT. So who else who are interested, please fill the Google form. One of from our end will connect you regarding the same to proceed with the registration process. Along with it, in the same course, we will giving you the placement assistance and the hands-on training and the small and the virtual exposure to the actual working real-time software such as SolidWorks, Autodesk softwares, and SIS MATLAB. Any queries? Hello. Okay, so this brings us to the end of this today's session. Thank you all of you for the participation. I'm very thankful to Charan for the grateful lecture. And stay connected with ISI India. We'll keep you updated about the upcoming webinars, courses. Thank you everyone.
Thank you, sir.